Hey everybody, my name is Silair Sileewa, and I'm going to be taking you through our Milestone 4, as well as the work that we've done in our previous 3 milestones for our Raspberry Pi voice assistant. So the goal of our Milestone 4 was to scale our application up by hosting our database on Cloud SQL, and the hardware required for doing this is similar to the hardware that is going to be required for the previous 3 milestones, which is the Raspberry Pi 4, which is the one that we have, but Raspberry Pi 5 would also work. USB microphone. This little small one is the one that we use. It's a little USB 2.0 microphone that's very discreet, very cheap. And also a set of speakers or headphones to basically listen to the voice prompts that the application gives you back. As far as what we've done previously, in Milestone 1, we developed the ChatGPT voice assistant that runs on a Python script that uses a Raspberry Pi 4 and a microphone and speaker, the hardware that we alluded to earlier. In Milestone 2, we deployed a VM that was powered by a Google Cloud Platform to act as a web server that displayed the data that we collected from the voice assistant. And in Milestone 3, we altered our Python script to give users the ability to create images using DALL-E 2. We also used Vertex AI in our Milestone 3 to create captions for the generated images and displayed them for users on the web server. As for what we're doing now, for our Milestone 4, we've decided to host our application on Cloud SQL on Google Cloud Platform rather than how we had it hosted before, which was just on a database that was located inside our GCP virtual machine. As for the why, we wanted to enhance the scalability and reliability of our application, as well as allow for ourselves to optimize our database using the tools that GCP provides. Such tools that Cloud SQL allows you to have, such as monitoring and as well as backups of data, and also being able to migrate your database to a different region if the region that your database is currently housed in goes down for whatever reason. And this will just enhance our scalability and reliability of our application. For the tech that we used in our whole application, we used Python, which obviously is the language that we use for our text-to-speech portion of our application. We used OpenAI's API, which allowed us to use DALL-E as well as ChatGPT. PHP was the front-end language that we used for our Nginx server. We used MySQL as the relational database, and it handled backups of our data as well as store the information that our users would give to our application. And then Google Cloud Platform is where the VM for our web server is located, as well as our Cloud SQL server that we host our database on. This is just a visualization of the tech stack that we used: MySQL, Python, PHP, Cloud SQL, Google Cloud, Nginx, Raspberry Pi, and OpenAI. Originally, we wanted to implement a NoSQL server instead of the current relational database that we had used in previous milestones, as it would allow us to scale our application linearly compared to what we have now with a relational database. However, we ran into a ton of issues with Cloud Firestore, and almost all of the issues that we ran into came in actually connecting our database to our existing code. There is documentation for Cloud Firestore. The issue is, as is the issue with a lot of Google Cloud Platform technologies, the issue is just finding that documentation. And oftentimes, I can just speak from experience. In a previous class, I used Cloud Firestore, and it looked one way, and when we went to go implement it this time in our application, it looked completely different and also functioned differently. So that was an issue that was presented to us, and we decided to just transition to using Cloud MySQL instead of hosting our application or our database, in our virtual machine. And we believe that this solved a lot of the issues that we wanted to solve in our Milestone 4, but it also doesn't close the door for us to be able to transition to a NoSQL database, perhaps maybe MongoDB or maybe even Postgres. So as for where we want to go next, aside from what I've mentioned a little bit before, transitioning to a NoSQL database, we want to transition our web application potentially to a web application to negate the need for a Raspberry Pi. So we know Raspberry Pis are pretty expensive to come by, and they're also just a piece of hardware that isn't completely necessary for our application. We want to also, in tune with this, add the ability to run prompts from our web server. Currently, the web server hosts a lot of the data that we have, but it doesn't really allow for a way to send prompts, voice prompts, or text prompts to the Raspberry Pi into our script. And then as well, we want to leverage some of the newer APIs that are more powerful, such as Stable Diffusion, ChatGPT 4, and DALL-E 3. Currently, we use ChatGPT 3.5 Turbo for the text to for the modern language to text prompts, and then for the text to image prompts, we use DALL-E 2 instead of DALL-E 3, mainly just because it's cheaper, but also because DALL-E 3 presented us some issues when we were trying to run it. And the reason that we want to leverage some of these newer APIs, aside from them being very powerful, is because a lot of these APIs, just like I'll talk about Stable Diffusion for a second. Also, Midjourney is another one. A lot of these I should say, have a pretty lengthy setup process as compared to what we've done, and they're not as straightforward as, for instance, going to OpenAI and using ChatGPT. It's a little more involved than just clicking a button. So potentially adding that to our application would make it more robust for users and would add a lot of functionality that users would see as useful. And that's it for my portion. Now we'll get on to the video demo where Daniel will take you through the flow of our application. Thank you.
This is Daniel. I'll be doing the demonstration for Milestone 2. Our project was the Raspberry Pi voice assistant, and I'm going to jump straight into the functionality test. So, within our directory, we can run our Python script to get our voice assistant running. And once we run this, it'll be actively listening for a wake word, and in our case, it'll be hey. So I'll wait for the script to run. Hey, what is a Raspberry Pi? So you can see our script listened to the wake word, got our question, and you're about to hear the response from ChatGPT as soon as that's given to us.
A small and affordable single-board computer designed to encourage teaching of basic computer science in schools. It is developed by the Raspberry Pi Foundation, a UK charity organisation. The Raspberry Pi board consists of a system on a chip, SoC, that includes a CPU, GPU, RAM, and other components.
I muted it just so we don't have to listen to the entire response, but you can see after our question was sent to the API, our data was inserted successfully, and that was our function that sends our data as post requests to our web server. And so let's take a look at our web server. This is from a previous test, so now when I refresh my page, you can see the response that we just received from Raspberry Pi on the previous screen, as well as the question. And you can see the question was asked at 228.26, and in usage we can see 228.26, as well as all of the hardware usage for the Raspberry Pi. And along with this, in our demo, we'd like to show our script actually successfully running. So on my VM, I'm currently in my home directory, and so I'm going to head to cron weekly to show our script. The reason I'm in my home directory is because this is where the backup files are going to be saved. So I wanted to show that we don't currently have any backup files. So once I'm in cron weekly, I can see, nope, that was ls. Since I'm in crawl weekly, I should be able to run that backup script, which is a shell script. And that was a success. So if we head back to my home directory, should be able to see that we have our backup of our SQL database. So that concludes our demonstration for Milestone 2. Thank you for watching.